Welcome back to EESC 418A. This is Lecture 5D, our final lecture on grammar and style. And in this talk, I'll be speaking about communicating uncertain information. And I'm mainly going to be going through a whole bunch of different terms that we use in technical writing and getting really precise about what is the definition of that term and when should we use it. So to start with, I'd like to just talk about uncertain information generally. Virtually everything that we discuss in science carries some level of uncertainty. There are some exceptions. We would say that scientific laws, very precise measurements, provisional and agreed to facts, and some defined terms, we can debate exactly what it means to be completely certain or to have no uncertainty whatsoever. But these are certain enough that we can have a reasoned discussion and just agree to these as facts. So how do we communicate everything else? So there are lots of different sources of uncertainty depending on the type of scientific information we're talking about. In earth and environmental science, we always have the problem of lack of measurement. We can't measure everything in the world. We have errors associated with each individual measurement as well as the collection of measurements. We'll have some level of instrument error. There can be contamination of our samples, both in the field while we're sampling, as well as in the laboratory when it's being analyzed. There's always the problem of spatial and temporal coverage. Have we sampled enough? Do we know exactly what's in between the two samples that we measured? And are the two samples that we measured representative of everything in between? If we've put our data into some sort of a model, that model will have some errors associated with it. Even simple models tend to have some level of error. There can be calculation errors. These are induced by the person calculating estimates as well as the method of calculation. There can be procedural errors depending on what sort of procedure we're doing. It will induce some sort of an error into our overall estimates. There's always some randomness that we can try and account for as best we can using statistics. But at the end of the day, we don't really know exactly what that random error is. There might be systematic errors. Of course, there's human error in everything we do, or the potential for human error, and it's tough to know for sure that we've accounted for all of that. Transcription error relates to writing data down, moving data from one spreadsheet to another, transferring data from a spreadsheet to a model. Anytime we're moving data from one medium to another, we run the risk of inducing some sort of a transcription error. Conceptualization error is usually the worst or the most gross type of error there is. If we've conceived of our problem incorrectly, then virtually everything we do after that will be wrong to some degree. We have some uncertainty around future conditions, especially if we're making model predictions or using some best estimate to make some predictions about what might happen in the future. And then we have uncertainty about past conditions. We might have measured something in the past, but conditions around that sample might have been different. We might not be able to go back and understand it, even though we might have some source of information like an aerial photograph. There will always be things about the past that we have no ability to go back and verify. So with all of these different sources of uncertainty, we need to be very careful about how we relate to uncertain facts, predictions, etc. So let's go through these one by one and talk about what are all the different uncertain types of statements we might make. There are a lot of different terms that we might use, and we might use these without thinking too carefully about what they mean. So the first is speculation. Speculation and conjecture are fairly similar. Thoughts, beliefs, and opinions. These have fairly common everyday language definitions. Some of them have scientific definitions. You can have a look at the rest of this list. We'll go through each of these terms one by one. So speculation and conjecture are fairly similar. So speculation is theorizing or conjecture. So not a very useful definition from the dictionary because we're also going to be talking about theorizing and conjecture as distinct activities. So I've added some flavor to these definitions. These are really working definitions. So speculation implies an uninformed opinion that should carry no weight. In other words, we're just speculating. We don't really know. It's basically just kind of a guess at what we think might happen or what we think might be the case. I would avoid speculating in all forms of technical communication. That applies to technical writing for sure, but also technical presentations, any sort of verbal presentation. We don't want to speculate, especially if we have some sort of a professional accreditation. If we're a professional geologist, professional chemist, an RP bio. Any of these things can jeopardize our professional practice if we're making speculations that could come back to haunt us. So I would avoid speculating. It's fine in casual conversation, but anything that will be taken as professional communication should avoid speculation. Similarly, conjecture is guesswork, opinion, or theory based on presumption of insufficient evidence. Again, this is fine in casual conversation. It's interesting to make conjecture. It can sometimes lead to a theory or to some good idea. But in terms of presenting our technical work, we want to avoid any sort of conjecture. Again, we want to avoid that not just in writing, but in all forms of professional practice. If we are speculating or providing some sort of conjecture, we need to be very clear that this is just some personal thought and it is not related to our professional work. Similarly, thoughts and beliefs. So a thought is an idea or a pattern of ideas. It's useful in discussions, should not be included in reports without supporting information. If we have some thought on some matter, sometimes as a consultant, we might be asked to provide our thoughts, but in that case, we should be clear to provide our professional opinion, which I will speak about on the next slide, and we should leave our thoughts aside. Same with our beliefs. The definition of a belief is the conviction that something is true, especially the teachings of a religion. So these are right out of the dictionary. So when we start talking about beliefs in science, somebody could rightly question whether we're speaking from conviction or whether we're referring to some data set. So do not use the word beliefs or believe. I believe that. You should replace that with the data suggests that, provided that's true. And if the data don't suggest that, then stay away from that belief altogether in your technical writing. Again, it doesn't mean that you don't converse or think about these things. It's useful to go over thoughts and to brainstorm with people. But in terms of a technical document that you would put out that is going to be full of evidence and data, and you're going to draw some conclusions from it, you really want to leave your thoughts, beliefs, speculation, and conjecture aside. Opinion is an interesting one because we have a personal opinion and a professional opinion. And if we're giving an opinion on something, we really need to differentiate between our personal opinion and our professional opinion. So our personal opinion usually relates to some value, something that we think should or shouldn't happen, and it will also relate back to our beliefs and thoughts that we've discussed previously. So we should avoid bringing our personal opinion into technical writing. In fact, it will almost always make us look biased, and that is really fatal or can be fatal to a scientist. It's not good for our credibility. So if we're providing a professional opinion, we need to be really clear that this is a professional opinion. And professional opinions can be valuable. People will actually pay you good money to provide a professional opinion. However, that professional opinion must be backed by years of science. And usually when you're providing a professional opinion, your credibility, your professional accreditation, and all of that is on the line. In other words, if you are providing professional opinions willy-nilly, you're going to lose your accreditation. So you must stick closely within your scope of expertise. For an example, I might give this professional opinion in a report if I'm asked to review somebody else's report. In my professional opinion, the company has applied an appropriate level of care in the design of this sampling program. It's very specific about what my opinion is, and I've clearly stated that this is my professional opinion. Whatever my personal opinion is of that company or the report is totally irrelevant. Next, we have a theory and a hypothesis. These are very well-defined scientific concepts. So stick to those definitions and don't use theory to mean anything else except for the scientific definition of a theory. So that definition is an organized body of ideas as to the truth of something derived from facts. And that's a really key point. Otherwise, we're dealing with a conspiracy theory or some crazy idea. It doesn't help us. It can actually get us into a lot of trouble. So don't confuse a theory with conjecture or speculation. It must be derived from facts. Similarly, a hypothesis is an idea or proposition used to explain certain facts or to provide the foundation of primary assumption of an argument. So this must be testable to be of value. A hypothesis that is not testable has no value whatsoever. So always be careful If you're providing some sort of a hypothesis, you must be able to say how that hypothesis could be tested and invalidated. So, some more terms that denote uncertainty: predictions and projections. In this case, we're usually talking about the future, although predictions can be sometimes made about events in the past or hindcasted, something that's unknown that's already happened and that can be verified. However, usually it is to make known, to foretell the future. So predictions are a necessary component of environmental impact assessment. Make sure your basis for prediction is well documented. We have to make predictions. We have to be able to say the impact of some project will be X, Y, or Z. And then we must be able to back that up and say why we believe that. So that would be based on a model, based on the similar impact we've seen from a similar operation, or some other line of evidence that we can clearly use to support that prediction. A projection is similar, but a projection is usually derived from a model, and it's usually about a future outcome, and it's usually some projection over time. So just to summarize predictions and projections, I'm going to quote Yogi Berra with a famous quote about predictions. "It's tough to make predictions, especially about the future." Very true. These next few words are fairly similar and almost interchangeable in everyday language. But in scientific writing or technical writing, we need to be very precise about how we use them. So let's go through the exact definitions and talk about when we would use one or the other. So probability is the likelihood of an event based on the ratio between its occurrence and the average number of cases favorable to its occurrence. And the key point here is that this is related to a number that we would derive usually using statistics. So use only with appropriate statistics and quote the statistics. So if we say there's a probability of something, we should be able to say what that probability is, as well as how we derive that probability. Now, this is closely related to the word probably. We would generally avoid the word probably in technical writing. It's somewhat ambiguous and not very specific to what that probability is. So if we use probably or probability, we really need to have a number between 0 and 1 derived by some statistical measure that we can cite. Likelihood: probable, plausible, and credible. Likely usually means greater than 50% probability. It's usually not statistically defined. It's usually something that is actually a lot more than 50% probability. But to be cautious, we would just say likely, even though we may think it's nearly certain. We don't get into whether it's 65 or 75% likely, in which case, if we knew that information, we would have used probability. So likely generally means more than 50%, and usually it means quite a bit more than 50%. Otherwise, we need to use some other term. Plausible means apparently true or reasonable. It's possible, but usually with a low probability of likelihood. So plausible means that there's no way we can rule this scenario out. It's theoretically possible, but generally this is something that has a very low probability or a low frequency of occurrence. It's just something that can happen. And here's a few words that we might use. There, I just used it. We might use this in technical writing. So we actually would not use the word might in technical writing, not very often. We might use it in a technical presentation when we're speaking off the cuff, but we tend to use the word may. So might, the definition is used as an auxiliary verb to express a probability less than that expressed by may. However, we don't really differentiate between might and may. We typically just use may for everything. So may is used almost universally in environmental science to express a future event with unknown probability, but we know that the probability is less than 1 and greater than 0. So in other words, it's not 0, it's not 1, it's not certainly not going to happen, and it's not certainly going to happen. Everything in between, which is almost everything, particularly if it's something about the future, we would say this may happen. And that might sound like what some people call a weasel word. However, we really don't have a better basis than this unless we are using some probability, in which case we can cite the probability. Will or shall, these express some certainty, so only used for certain future event. And again, almost nothing is certain about the future. However, it is used in regulatory orders where the government will say the proponent shall do this, or the company shall do that, or will do that. in which case they're ordering something to happen. Finally, we have some terms that express a level of knowns or provisionally accepted facts. So we say these are provisionally accepted as true, subject to implied or stated uncertainty. In other words, we can't say for an absolute certain fact that something is true, but it's true enough that everybody who's reasonable would agree on it as a fact so that we can move forward and focus on what we're trying to accomplish. So facts, usually given with a reference to a true source such as a peer-reviewed article or government document. And I've quoted true because, again, this is provisionally accepted. It doesn't mean that those are absolute, unassailable facts. It means that we're going to agree that that source is reliable so that we can move on and make some interesting conclusions. Any sort of a universally accepted fact does not require a reference. In other words, Victoria is the capital of British Columbia. I don't need to cite some document. Pretty much anybody who would care about that fact knows it's true. So we can just move on without citing every single sentence in the document. Data, measurements, observations, and evidence. These all refer to information that was measured or observed, and it's replicable. So somebody else using the same methods would have measured the same thing, and it's objective. It doesn't matter what our opinion was, the measurements speak for themselves. Data really just refers more to quantitative information or numbers. Measurements can be normally data, but not always. Observations might be something we see or something we measure, and evidence can be any one of these. These can be a line of evidence. Evidence can also refer to something that's calculated from the data. The key point here is that these are replicable and objective. And finally, conclusions. A conclusion is a reasoned judgment or inference. It's based on the lines of evidence provided. So the types of evidence on the previous slide make up lines of evidence from which we can draw a conclusion. A conclusion is not a restatement of the results or a discussion, and it's not speculation or conjecture. It is something that we would state as something that we've learned or something that we think, strictly based on the lines of evidence that we've provided throughout our report, and now we're trying to conclude something meaningful from that. Again, the conclusion must be bounded by the uncertainty inherent in its supporting lines of evidence. So if we make a conclusion, the confidence that we have in that conclusion relies entirely on the confidence that we had on all of the supporting data. So, with that, be careful with these terms. Always be clear on whether you're expressing a probability or a likelihood or a professional opinion or some other science-based opinion. With that, we have concluded the grammar and style portion of this course, and we'll now move on and talk about some of the considerations for writing technical documents, and beyond that, we'll actually start writing some technical documents. So, thanks for sticking with me this far, and see you next week.